Twitter for hosting us. So I'm Marion from Switzerland. I came in today. If you want to follow me on Twitter, I'm Ruby Dwarf. Ruby because I started programming with Ruby and I love it, and Dwarf I don't need to explain because they had to adjust everything here just for me. So yes, first to explain myself, to introduce myself quickly. So my job, I'm a developer experience engineer at Hasura, which means I'm responsible for the whole documentation for building boilerplate apps and prototypes and going to conferences, events like this. But basically I'm responsible for the developers that are already using Hasura and to make sure they have the best possible experience. And I've started the job last Monday, so I'm really happy. So in my free time, I'm also a community organizer in Zurich. I'm running a few meetups, for example, the GraphQL meetup and the Women Techmakers and some others. And on weekends, I'm a mechanic for my boyfriend who is doing motocross. So when he bought a new bike, I read the whole 450 pages manual, so I know everything. And a few weeks ago, I started riding myself, so we'll see where this is going. Okay, so first of all, quickly the agenda of today. First, I want to ask, who is new to GraphQL here? Okay, so quite a few people, so I will give an introduction to GraphQL as well, otherwise I would have skipped. Then I want to introduce to you Hasura, which you can use to build your GraphQL project. And finally, I want to show you a new feature that we have, which is Remote Joins. Okay, first of all, GraphQL. GraphQL is a typed query language, and typed here is very important because compared to other query languages, you can avoid a lot of errors because of the type, so you cannot instantiate an object if it has the wrong type. This is my favorite, it has one endpoint. So compared to REST, we will come to a proper comparison later, but one endpoint. You can have nested resources. So if you have, for example, a user and a profile, a user that has a profile, you can get information from these two tables in one query. You don't have to get the profile and then the user ID and then get the user. You get it in the same query. Developer workflow is much easier, in my opinion, with GraphQL because if you have big companies that have front-end and back-end teams, it's easier to access the endpoint for the front-end developers because if they need something new, it doesn't have to be implemented first. And finally, you get the exact results. So for example, if you have a user and you only want the first name, you only get the first name and you don't have to get the whole user and then get extract the name from this. So this is from the official GraphQL website. This is how you would describe your data. So you have a type project that has a name, tagline, and contributors. And you can see here that it's typed, so you have to name what's the type for all the fields. Now we say from the table project, we want the one project that is called GraphQL, that has the name GraphQL, and we only want the tagline, not everything else that the project has. And this is the result that you get. So it's very straightforward. Now, as promised, let's compare REST to GraphQL. So with REST, you have an endpoint for every resource. So if you have users, you have a users endpoint, profile endpoint, and if they are nested, so if there are relationships, there is a lot of chaining involved. I will show you an example for this later. Then you use all the different HTTP methods like get, post, delete, and update. And the potential of overfetching and underfetching is pretty big because sometimes you only need one field of an object, but you get the whole thing, or you don't get enough and you have to get some other things. So this can, especially if APIs get bigger, can get messy. With GraphQL, you have one endpoint. It's always a post request, so you don't need to worry about HTTP methods, and you only get the data that you need. So now I learned GraphQL with Star Wars API, but I don't like Star Wars so much, so as soon as I knew how it works, I implemented my own Harry Potter API, which I will show you later a little bit, but now this is a REST example. So let's say we have a website with all the Harry Potter movies. So the endpoint would be /movies. Now I want to have a list of the characters of one movie. So then this would be the endpoint. And now you want to list the actors of the characters of one movie, and you see where this is going. So it can get very complicated. And actually, in January, I had to implement a REST API, and I did it in Ruby on Rails. And at the beginning, I was the only backend person, and the front-end developer said, yeah, we need this and this endpoint, and we only need create and list for this. And then in the end, everything changed, and I used so much time to implement this. And then just for fun, I did the same with the Hasura project, and the difference was 3 weeks and 3 days. So it's a lot of time that can be saved. Now, if you want to have a GraphQL project, you could implement your own GraphQL server, but you don't have to. You can use Hasura's real-time GraphQL API. So real-time, I think it's clear what this means. It means you don't need to reload you get instant updates. Then the whole project is open source, so if you're not sure how something is working, you can check it out anytime. Every Hasura project is running Postgres underneath. So this is something that is a little bit special. So the query comes in, gets parsed, and then translated to SQL, run against the Postgres database, and then sent back directly to the client. And so Hasura is at the moment the fastest GraphQL engine on the internet, and the reason is that it's written in Haskell. Maybe some of you have heard of Haskell. It's a functional programming language that is used specifically when you have to make things very fast. So the goals are to have low latency. If we make a query, we want to get instant feedback and not wait. High throughput, as I said before, if we have nested queries, there is sometimes a lot of data that has to go through. And it has to be light on resources, so we don't want to waste a lot of CPU and memory. Some of the features I will show you. So you can use any kind of authentication that you're used to. So Hasura doesn't have its own authentication, but you can use anything like Auth0, webhooks, and Firebase authentication, like anything, or even your own authentication service, and then connect it. For authorization, this is role-based in Hasura. So for all the tables, you can have, based on the row and also on the column, you can define permissions if a role, for example, you have users and admin, and the admin can access more than users, so you can define these permissions. There is also an allow list that lets you add queries that you think are safe to be made to your GraphQL API, and then the others don't get through at all. Data security is an important point. So if you have a sensitive project that cannot have data in the cloud, that is no problem. So you just run your project locally in a Docker container. So you never have to have data in the cloud if you don't want to. And maybe some of these the things that the database can do is not enough, so maybe you need business logic. So for this you would use event triggers on Hasura that trigger serverless functions in the cloud, and this can be any cloud. Yes, so for example, if you have a movie API and you have users that subscribe to new movies, then when a new movie is inserted, you can trigger a serverless function that sends emails to the user that subscribed, or payment service. There are several use cases here. So now I want to show you how this looks. So first of all, this is the landing page. So you can see to which, I might maybe have to make this smaller. No, anyway, so you can deploy your Hasura project to all kinds of cloud providers. So basically the project is always running in a Docker container, and you can deploy it to anywhere where Docker runs, which is almost everywhere. To get started, I would recommend the free tier Hasura code, so you can here just make a one-click deploy. So you just have to give the project name, and then here, and then you deploy the project. And now I don't want to lose time on this, but show you on an existing project how this looks. So when you deploy the project and you open the app, then you get to this Hasura console, which is empty. To run you through how it looks, here is the endpoint, again one endpoint that you have to configure. And if you have authentication, for example, you have an access token, then you would pass it here in the header. Here in the console you can try out queries and mutation, get the results here. Okay, so let's have a look at the API that already exists. So we have here movies, so this is the Harry Potter API. We have movies, and we can, these are the movies that I already have in my database. Then I can insert a new movie manually. This you would not do on a like production project because you will get the data from the front end. You can modify, you can add foreign keys, and here you have relationships. So from the movies perspective, you have you can have an array of scenes. So these are the array relationships and object relationships. I think probably most of you are familiar with these kinds of relationships. Yes. And an example for an object relationship is, for example, here a character has one actor and the other way around. So you can have both kinds of relationships. And then this is the permissions that I was talking about. So this Harry Potter API is open source. So if you too want to learn with Harry Potter, then you can totally use this one. But of course, I don't want to have people deleting my movies. So when you make a new table, the default is that you have an admin that can do everything: insert, select, update, and delete. But for the user, I only want to allow them to select. And here you can do the permissions more specific. So with custom check, and I can say, for example, the end is here is not really necessary, but this is a typical example that you would use. So if I have users, and one user should only be able to look at their own user data and change them, not the one of the other users as well. So I can say here, the user can use select on the characters table if the Hasura user ID is equal to the ID. So this way you would pass in the header again. And if you want to have more specific ones, I can say the user is not allowed to change the ID and the house, and the other ones they can change. Okay, so now maybe here I can also show. So this is where you would add event triggers and serverless functions. To get started, I would recommend Glitch because it's really easy to get started and just try out with JavaScript. If you want to use Ruby, you have to use AWS because it's the only one who supports Ruby. If I add an event trigger, I can track it here. So these are all the events and they were delivered successfully. So also there's the kind of logs where you can check everything out. Now let's make a query here. So I say I want movies, and for movies the title and the director. And then it shows me here the results. And this is what I mean when I say only get the needed results, because the movie also has an ID, a composer, and a release date. So I just only get what I need. And now, before we said a movie can have many scenes, so you can just use the nested child array basically on the table as if it were its own field. But I also have to define what I want from the scenes, which is, let's say, the name. And then you can see here scenes and an array. So you will get this. I think this is pretty clear. Does anyone know? Oh, maybe. I want to present. Okay, so remote schemas is something that you can use with Hasura. So you have your Hasura project, but maybe you have another GraphQL API. And then you just stitch them together with remote schema. And I can show this quickly as well. Where was I? Here. So let's say I have another schema, so I would just add it here as a URL, and then I can use it from the console here as if it were inside of this project. Actually, from here you don't even know if the data comes from this project or from the remote schema. And what's now new is that you can, first the situation. So in today's project, there are sometimes multiple third-party services like payment services or email services, multiple databases because you cannot keep everything just in one, and multiple microservices. So the source of truth is spread among projects or services, which can get messy. And now this feature is introduced. It's now a pull request. It will be merged, I think, next week. So now you can join data in your tables across data sources, even if they come from different data sources. What does this mean? So you have one centralized point where you can keep all the data, even though the projects can be maintained in different teams, for example. Then you get precise slices of data. So for example, if you have a payment API and you have a customer ID and you always have to get, for example, you want to have the email address that was passed to the payment service, and then you have to take the ID from the payment service, get the data, and then you can give it back. So with remote joins, you can have these all in one table, and it's secure. It's the same permission-based rule that you can use also on these remote schemas. And also, it's never possible to get, for example, with one query, the whole data from Stripe, for example, all the payment information, because it's always a field in your customer table, for example, so you can only ever get one, information from one customer. So it's not dangerous that you lose or you give away data that you shouldn't. Let's see some use cases. So, for example, Stripe, as I mentioned before, and I would do it like this. So first I stitch these two remote schemas together, and then I can use here a query, and I can say customer ID email. This is from my project, and then this is the relationship that I added called Stripe, and the account balance is retrieved from the remote schema, but can be kept in one table in my database. Another example is Auth0. Same here, I just name the relationship Auth0 profile and get all the information, because maybe I don't have the ID, the email, but I need it for some reason also in my database. And the third use case is if I have two different databases, not necessarily, doesn't necessarily have to be a third-party service, but two databases that I want to join. So maybe I have authors, and authors have articles, but the articles database is in a different project, but still I want to use them together because the article usually belongs to an author. So then I would also do it like this. I make a query, have my authors, that is my database, ID name, and this is from the articles database because I joined them together. So this example, we will see how it works in a demo. Yes, so this is our, let's check. Yes, our articles database. But here you can see with remote schemas, we added the authors database. So these are now together. But now we don't have any relationships yet. So now I can make a query, and I I can say author's name, and I will get here all the authors. Or I can say articles, and articles has a title. So basically I can query from both databases and see it here, but they are not connected. So if I want to have, I think article has author ID. So I get the author ID, but the author is not really in my database. So what I would have to do is go to the author database with the ID and get the author information back. But now what we can do is in the articles table, relationships, add remote relationship. We are now in the articles table, so we name the relationship author because every article has one author. This is from the remote schema, we just added one, so if there was many, I could choose here which one it is. And then we say authors by primary key. And here we basically say the ID from the author project should be equal to the author ID in the articles database. I think this makes sense. So then we can save the relationship. And now if we make a query, we can use here the author and say the name. And so we have them now together in one table. This can be pretty powerful if you have if you have spread your data across many microservices or you use a lot of third-party services. So now, this is still a pull request. So if you're already using Hasura or if you want to try, you can try remote schemas with remote joins in the pull request. Next week it will be released, so maybe you have time next week, so it will be already emerged. Then you can play around with it, and we would love your feedback. So the basis on how we decide what features to do next is what you developers want. So we would be really happy if you told us what we can do better, and maybe also what you like. And I would love to know which third-party services you would like to have. I mean, you don't have to shout it out now, but I will be here all evening. So these third-party services that are part of OneGraph, do you know OneGraph? It's like a client that helps you integrate third-party services in your GraphQL project. And all the services that are already GraphQL APIs, you can just integrate in your project with OneGraph. For the others that are REST, we will write boilerplate apps so that you can use them. But for this we need to know what you want. So I would be very happy if you gave me some feedback. Before I close, I quickly want to talk about the community. If you want to get into Hasura, there is a lot of learning material. So there's learn.hasura.io. There's a backend tutorial that shows you everything that I showed you now, like in 5 minutes in the console, but a little bit further explained. There's also tutorials for all JavaScript frameworks, for Flutter, Elm, like everything that you can use in combination with Hasura. Then the documentation is now, if you find something wrong there, then now you have to come to me because I'm responsible for documentation. So I would be happy about feedback. If you start using Hasura, there is a pretty active Discord channel. So if you have questions, you can just ask there and you will get an answer very quickly, because it's a pretty large community, and also users started answering questions of other users, and otherwise the team will always answer questions. It's open source, so you can check it out on GitHub. If you have a wish for the next feature, you can just open an issue and then other people can upvote it, and then we will do whatever is needed by the community. New features will be announced on Twitter, and maybe also interesting, so there is a support program, a writers program. So if you are not yet, if you don't have a blog post yet, for example, it will be a good opportunity to write your first blog. You will get feedback for everything for free, feedback and how you can improve your writing or like small typos that you have, and they will pay for every blog post that is published by other people. There's a talk program, so if you are not a public speaker yet but you want to be, we will help you making your slide, rehearse everything. And if you're a company that is not sure if you want to use Hasura or if it's something for you or not, then you can have free demo calls with the architecture experts anytime. So just contact me or on Discord. And with that, I want to say thank you. So these are my contact details, and you can contact me anytime. Thank you very much.
Thank you very much, Marion. If you'd like to ask any questions for Marion, then she's going to be hanging around afterwards when we have some drinks and food, so just go and grab her and ask anything you like. Now over to, okay, let's have a 5 minutes break and we'll get Uri set up and then we'll come back.